Hello, this is Keenan, and this is YLOC 4th grade worksheet lesson 7. To start, our first section is the area of a rectangle. The area of a rectangle is the length times the width, or this formula, area is length times width. So for our first problem, we have 2 centimeters times 3 centimeters. When you multiply those together, 2 times 3 is 6, and because we have centimeters times centimeters, we get centimeters squared. So remember, centimeters times centimeters equals centimeters squared because, oh, that's a bad 2, but whatever. Any number multiplied by itself is that number squared. Problem number 2, we have a very similar type of problem. 2 inches times 5 inches. 2 times 5 is 10. And then we have inches squared. And then for this, we have 9 feet times 7 feet. 9 times 7 is 63. And then we square the feet. Oh, that is not supposed to be there, that dot. Ignore that dot. It's just 63 feet. And then for this next problem, 2 times 5.5, that's 11. And then meters squared. And here we have 31 times 197. If we do some math, we'll find that that's 6,107 centimeters squared. For our next problem, we have 4.2 inches times 6.9 inches, which will give us 28.98 inches squared. So all of these problems, as you can see, they're just simple multiplication. You just multiply the numbers and then you make sure the units are correct. And then for our last two problems, 0.99 meters times 1.01 meters gives us 0.9999 meters squared. And then lastly, 11 times 123 is 1353 miles squared. Moving on, we have the area of a triangle. The area of a triangle is 1/2 base times height, or 0.5 times base times height. If all lengths are in centimeters, what is the area of the triangle? So here we have 3 as the height, 2 as the base. Remember, we're doing 1/2 times base times height. So it's very similar to those rectangles we just did. It's just we also need an additional 1/2. So 1/2 base times height. Here that's times 2 times 3. So that will equal 3. So our answer is 3. And don't forget, the lengths are in centimeters. So we have centimeters squared. Next problem, very similar. 1/2 times 7 times 8 is 28 centimeters squared. For this problem, 1/2 times 5 times 3. 5 times 3 is 15. 15 divided by 2 is 7.5 centimeters squared. This problem, we have 4.5 times 8 times 1/2. 4.5 times 8 will be 36. Times 1/2 is 18. 18 centimeters squared. And then here we have 100 times 1 divided by 2, which will be 50 centimeters squared. Next problem, 1 times 100. 1 times 100 is 100 divided by 2 is also 50 centimeters squared. And so you can see that even if you switch the base and the height, you will get the same answer, because if we look back at the formula is 1/2 base times height. And so since they're all just being multiplied together, none of them is like stronger, none of them has like a preference or affects it more. So we should be able to switch them without having a different answer. And then this is a little bit of a challenge problem. The bottom part is a square for this pentagon. It's a 5-sided figure. If I trace it out, 2, 3, 4, 5, you can see it has 5 sides. And the bottom part is a square and the top part is a triangle. So in order to solve this problem, we know it's a square, which means all its sides are the same. That means this side is 4 centimeters, so this bottom is also 4 centimeters. Now we can use the length times width formula we just learned to do 4 centimeters times 4 centimeters gives us 16 centimeters squared. So this part is 16 centimeters squared. Now we compute the triangle at the top. So once again, it's a square, so we know that this side is also 4 centimeters. And then we use the other formula, 1/2 base, which is 4, times 8 centimeters, which is the height. Well, I should have centimeters for this too, technically. And then that will give us 16 centimeters squared as well. So we have 16 centimeters squared here, and 16 centimeters squared here. So you add those together to get the total area, which will be 32 centimeters squared. And then our last problem is another challenge problem. This one is actually pretty difficult. Can you find a formula for the area of a trapezoid? It's a quadrilateral that has one pair of parallel sides. And use this image as a hint to get you started. So in these images, we can see that somebody drew these lines in the trapezoid to make these right angles, which will make this center part a rectangle. Same thing here, except for this trapezoid, one of the sides was already a right angle, so there was no triangle to cut off. So to solve this, I'm going to have to first name a few things. I'm going to call this one at the top base 1. That's going to be the length of the top side. The length of the bottom side will be base 2. And then, oh, that looks like a 62, sorry. And then, since it's a rectangle, we know the other side is also base 1. That's only from here to here. And then we have some other extra bits. The extra bits I'll just call E1 and E2. So to find the area of the trapezoid, we'll just say, oh, this is also height. So we'll add the area of the triangle, the rectangle, and the triangle. So firstly, the rectangle's area is just B1 times H. And then we'll add the first triangle, which is E1 times H over 2. So 1/2 E1H. And then another 1/2, this is the second triangle, E2H. And then this is going to be pretty advanced. We're going to factor out an H from all three of these, which will leave us with B1 plus 1/2 E1 plus 1/2 E2. And then this is another advanced step. We're going to separate this B1 into 1/2 B1 and 1/2 B1. 1/2 B1 plus 1/2, oh, that's not 1/2, 1/2 B1 plus 1/2 E1 plus 1/2 E2. Now we have this line here. E1 plus B1 plus E2 makes B2. So 1/2 B1 plus 1/2 E1 plus 1/2 E2 makes 1/2 B2. Wow, that's crazy. And then so our formula is H times 1/2 B1 plus 1/2 B2. We can factor out the 1/2 to get our final formula of B1 plus B2 over 2 times H. So that is our formula. And because of the way I solved it, if you do the same thing for this trapezoid, where we say that's B1, this thing is B2, and this is E1, and this is height, this will still work without the E2, because all we have to do is erase this E2, erase this E2, erase this E2, and then we can just have 1/2 B1 plus 1/2 E1, which we have the same thing here, B1, E1, B2, 1/2 B1, 1/2 B1, E1, 1/2 B2. So it's the same thing. So this is the area of a trapezoid, B1 plus B2 over 2 times H.